So in this video, I'm going to do a few applications with E. The first few are actually a pre-calculus concept, so that you should have seen in previous classes, and then we'll get to the calculus of it. But this is the compound interest formula. A of t equals PE to the RT. P is the principal, which is the amount vested at the beginning. R is the rate as a decimal, and T is the time in years. So for this example, it says how much will be in an account after 5 years if 1,000 is invested at an annual rate of 8% and compounded continuously. So anytime they say compounded continuously, we use this formula. P is the amount we invested, so that would be 1,000. R is the rate as a decimal, so 8% as a decimal. Okay, so to find R, you can either take 8 and divide it by 100, which gives you 0.08. Or if you think about it as moving the decimal places here, you move it 2 to the left. So it becomes a 0.08. Either way gives you the rate. And then T would be equal 5. And so pretty much we just plug that into our formula. So A of 5, because T is 5, would be 1,000 E to the 0.08 times 5. And you can type this all in your calculator. So you would type in 1,000. And then E is if you hit second, and then this like ln, it has e to the x in blue, and it brings it to an exponent. And then I would put 0.08 or 0.08 times 5. And just make sure both are in the exponent. If you have an older calculator, it might do like the caret after it and then parentheses, and then you need to put 0.08 times 5 and like write it like that if you have an older calculator. Just make sure you're getting the same answer if you have an older calculator. So if you multiply that, you should get this. So it would be 1,491.82. For these problems, because it's money, we usually just do 2 decimal places. So that would be my answer. So again, this doesn't involve any calculus, but we are going to get to problems like this that do involve calculus. Okay, so B says, how long will it take for the money to turn to 6,000? So in this case, I'm trying to find T when A of T is 6,000. So when they give you the end amount, that's A of T. And so we're going to assume that P is the same and R is the same, but that we no longer need T. So what in this formula, I would plug 6,000 in for A of T, 1,000 in for P, E, and then I would put the 0.08, and then I'd put a T. And then we have to solve this for E. So the first thing you want to do is move the 1,000 to the other side. We do that by dividing both sides by 1,000, because our goal is to get T by itself. So that gives me 6 equals E to the 0.08 T. And then hopefully this sounds familiar, but whenever you are trying to solve for it with an E, you use the inverse of E, which is the natural log function. So you take the natural log of both sides. And what happens is we can use that rule again before, where the 0.08 T is the exponent on the part that's inside the natural log. So that can be moved to the front. And then ln of E is just 1. So this becomes ln of 6 times 0.08 T. Okay, and this is times 1. ln of E is always 1. So this is just ln of 6 equals 0.08 T. And then because I'm trying to get T by itself, I can divide both sides by this 0.08. And so I would type this in my calculator to get T. I would take ln of 6, so ln is here. Okay, close your parentheses and then divide by 0.08, and that would give me the time, which is about 22. We'll just do 2 decimal places again. Okay, so it's 396. So the 9 bumps up to a 10. So it becomes 40, and that would be in years. So hopefully you've seen this before. We won't do too much with it, but some of the application problems may require you to solve for t using the natural log. Okay, so one more. How long will it take to double the money? Okay, so we're assuming that, kind of back to A, that our principal again is 1,000. So double would mean A of t is 2 times that, which is 2,000. And so we're going to do it the same way that we did part B, but we're going to plug 2,000 in for A of t. And then we are going to leave, again, t, because we're trying to find how long or the time. So we solve this the same way. We get E by itself first by dividing both sides by 1,000. So we get 2 equals E to the 0.08t. Okay, anytime I have E as the base and I'm trying to get the variable in the exponent, we take the natural log of both sides. Okay, so we have ln of 2, and a lot of students generally skip, and that's fine. Ln of E are inverses of each other, so this, it just becomes 0.08t. It's kind of how it always works. This one too. Ln of E, it becomes the 0.08t. So what you could do is that if you want to show like all the work, it would be bringing the exponent to the front again. And then again, ln of E just becomes 1. And then that gives us where we got to here. And then the last step would be to divide both sides by the 0.08 to get the t by itself. And then I have t equals, and I'm going to type in my calculator, ln of 2 divided by 0.08, which gives me 8.66 years. Okay, so staying with that problem, or a similar problem, we're now going to get into like, what does this have to do with calculus? So it says 400 is invested at 3% compounded continuously. So we're using that same formula. The amount in the account after t years is given by this. So they did give you the equation this time, but again, they just plugged in the P and the R into that general equation for compound interest, which is the PE to the RT. Some people remember it as PERT. This says, what is the instantaneous rate of change after 5 years? So this should look familiar. Instantaneous rate of change always means find the derivative. And then we're going to plug in that t equals 5 for it. So this goes back to the derivative of E. Okay, I have a constant, so that stays in front. Yeah, the derivative of E is itself. We leave the exponent the same, and then we multiply by the derivative of the exponent. So the derivative of 0.03t is 0.03. Okay, I can multiply the 400 and the 0.03, which gives me 12 e to the 0.03t. So this is my derivative. Again, make sure you use proper notation so that you put the apostrophe with the a. And then they wanted it at t equals 5. So I'm going to plug in 5 for t. And then to solve this, you have to type it in your calculator. So you have 12, hit second, then that e, which is the ln, and then type in 0. I didn't want the L in there. And then for the exponent, 0.03 times 5. And so that gives me 13.94. So the instantaneous rate at time t equals 5 is $13.94. So the amount in the account is changing by $13.94 at time t equals 5. So between the 5th and the 6th year, pretty much, it's changing by $13.94. Okay, so for one other application, we have in 2009, the estimated world population was modeled by P of X equals 6.8 e to the 0.0114x, where X is the number of years since 2009. What is the instantaneous rate of growth in 2025? Now, because they said since 2009, to get the X value, we take 2025 and we subtract 2009. And that gives us that 16 years. So that's how they get, so that's my T value. Okay, you don't want to plug in 225 because the time they said is since 2009. So again, the question asks for the instantaneous rate of growth. Anytime it says instantaneous rate, I want to take the derivative of whatever my function is, and then I'll plug in the X or the T value that they want. Sorry, they used X for time and not T, so let me change that to X. Okay, so the derivative of this is the 6.8 stays there. The derivative of E is itself. You keep the exponent the same, and then you multiply by the derivative of the exponent, which is 0.0114. And then I'm going to multiply the 6.8 by the 0.00114 to simplify it. Okay, and that gives me 0.07752 e to the 0.0114x. Okay, so that's my derivative. And then I want it again at 2025, which is where I plug in 16 for x. And again, I'm going to use my calculator. So I have 0.07752. I'm going to hit second and then that ln to bring up the e. And I'm going to hit 0.0114 times 16 in the exponent. Okay, so the instantaneous rate of growth at time t equals 16 is what I just got here, the 0.093. I'll do 3 decimal places since we're not talking about money. Okay, so the population is changing by 0.093, I guess, people in the year 2025. So those are examples with the application of E, because there'll be one more like the compound interest one on the take-home quiz for take-home quiz 3. So if you have any questions, just let me know.